Assalamualaikum everyone. So we already cover IIoT reference architecture part 1 in the previous class. So today we are going to continue with IIoT reference architecture part 2. For today's class, we're going to look into the architectural topology and the topic for the connectivity, gateway, and also the key system characteristics. The architecture of IIoT is very complex, where there are a lot of components that need to be considered by the manufacturer, by the industry, when they want to transform it into the IIoT. Okay, so as we know, we do have a lot of what we call sensors. There will be a lot of data coming in, and there will be also protocols and all the technologies that need to be what we call to map into the system. So in order to make it easier for all the manufacturer and all the industrial player to design and to architect their IoT, they come out with a very simple way of what we call design for the manufacturer to follow. There are three tier design that can be followed by the industrial player when they want to design the IoT for their factory. Okay, so this architecture, this tier, supposed to be supporting from what we call from the beginning till the end of the process, when all of the products is being delivered to the customer. Okay, the best way to visualize this IoT system is through the three-tier topology. There are edge tier, platform tier, and also enterprise tier. Let's see the these three tier in terms of illustration, so that it will be easier for us to understand. Now, um, when we look into these things in illustration, so you will see that there are edge tier, we have platform tier, and the third one is enterprise tier. So the first tier is more related to the sensors, to all the end nodes where the data is collected. Okay, so usually it is related to the machine to machine connectivity. It depending on the sensors that we use. Okay, so before it goes to the edge gateway, so this is where all of information will be gathered. Okay, so and it will go through the edge gateway. So this one we're going to look into the detail of the edge gateway. Before it is transformed to the platform tier. In the platform tier, all of the information will be gathered, and then the analytic and also what we call the analysis of the data will be done, and also the data also will be stored in the platform tier. Okay, so and the last one is the enterprise tier, where this is where the domain applications, the rules and control, and the management of the data is performed. Okay, so if you can see from one tier to another tier, there are certain connectivity that we have to look into. And for example, in the edge tier, from all the end nodes to the edge gateway, it is using the proximity network. Okay, and then from edge gateway towards the platform tier, we use the access network. And lastly, from platform tier to enterprise tier, where all the data is coming back and forth between these two. Okay, so we use the service network. Okay, so let's see the first tier, which is the edge tier. The edge tier is where all the data from all of the end nodes is collected, aggregated, and transmitted over the proximity network to a border gateway. So depending on the protocols, technology, all the type of sensor, they are using different language, right? So this is where all the data is what we call collected, and then they will be what we call change it into a certain part that can be translated and be analyzed later by the next platform. Okay, so some data translation and interface integration may be applied at this hub, and then remote input output devices or protocol converter. Okay, so that's what I mean. They convert it into some readable data so that it will be easier for the uh, next platform to analyze the data. And then in this H tier, it usually contain the function for the control domain. Okay, so if you don't remember what is control domain, go back to the slide in the previous class. Okay, on we already see about the viewpoints, right? So if you can see, we have the usage function where one of them is the control domain. Now let us look into the second tier, which is the platform tier. For the platform tier, it will receive all the data that are gathered in the H tier over the access network, and then it is responsible for data transformation and processing. It will analyze all the data that come from the what we call from the H tier into something that is usable, and it can be read by the other people. Okay, so the platform tier also responsible for managing control data flowing in the other direction. For example, from the enterprise to the H tier. Okay, so it's become the middleman lah in between the H tier and also the enterprise tier. Okay, so it is within the platform tier that we will locate the majority of the function related to the information and operation domains. And the last one is the enterprise tier. So the enterprise tier implement the application of the business logic for decision support system and end user interface, such as for operation specialists. Okay, so for example, all the data that are already being analyzed will be transformed into something that can be seen by the customer, can be seen by our engineer, can be seen by people. Okay, so that it will be easier to be translated into something beneficial to the enterprise, to the company. Okay, so this tier hosts most of the application and business domain function. In the previous figure, we also can see that there are relationship between functional domain and the three-tier architecture. However, this functional domain is not what we call exclusive. It is not assigned just for that certain tier, because it can be used in all these three tier. Okay, it is not just specifically for tier H tier or platform tier or enterprise tier. It's usually interrelated to each other. Sometimes it can be in between the H tier with platform tier, and sometimes from platform tier to the enterprise tier. Okay, so other than that, there are also some function, for example, data transformation, that can take place in different tiers also. It does not what we call between the H and platform tiers only. It can also be from platform tiers to the what we call to the enterprise tier, uh, and enterprise tier to the H tier. But from enterprise tier, usually the platform tier will be the mediator in between these two tiers. Okay, so the data transformation in the H tier is device or protocol specific. So why it is said like that? Because we gather the data from sensors. We get it from the machines. Okay, so it is very device what we call um, uh, related. It is very device dependent. Okay, so that's why there is certain protocol involved with that, because each of sensors and each of the devices might have their own language for this one. Whereas in the platform tiers, data transformation is a function performed on all the aggregated data. Okay. Now, let us look into the different network that connect the tier. If you can see in the picture previously, we have the proximity network, we have the access network, and also the service network. So let's see the proximity network. So the proximity network usually connect the sensors, actuators, device, control system, so everything that related to M2M. Okay, so is using the proximity network. Okay, so it typically connect these edge nodes as one or more cluster related to a gateway that bridge to the other network. Okay, so the next one is the access network. This access network will enable connectivity for data and control flow between the edge and platform tier. Okay, since the data is being transformed from this edge, from this gateway towards the cloud, or towards the storage area, or towards the analysis area, so it's usually can be transformed using the corporate network. It can be overly private network over the public internet, or it can also can be 4G or 5G network. The last one is the service network. This service network enable the connectivity between the services in the platform tier and also the enterprise tier. And it also can be used for the what we call the service within each tier. Okay, so it can be an overly private network over the public internet or the internet itself. Okay, so this one will allow the enterprise grade of security between end user and also various services. Now, when we revisit the picture here, the image here, we will see that there is a part in between the what we call the edge tier to the platform tier, what we call as edge gateway. So let's see what is edge gateway here. Edge gateway, or we can call it gateway mediated edge, is a device which it is the purpose for this device will be to aggregate the data flow and also the connection from the end nodes and also the homogeneous network gateway. So this one, what happened is each of the end nodes, for example, the machines, the devices, and also the sensors, they have their own connection, they have their own data, and also what we call the protocol. Okay, so what happened at gateway mediated edge is they will transform, it will make it into one single point connection before it goes into the wide area network, or into the platform area. Okay, into the platform tier. So this gateway, it will what we call it will become the middleman, middle devices. It change all of this connection into one single source of connection only, so that all the data will be standardized before it goes into the platform tier. It will not one is Bluetooth, one is Wi-Fi, one is another methods of connection. So it is going to be very difficult for the platform tier to aggregate, to do the what we call to analyze all this data together, because the connection is different, the protocol is different. So that's why gateway is what we call put in the middle there before it goes into the platform tier, so that all of this data, all of this information, and all this what we call the connection, connectivity, it is sort into something that is only one single connection only, and while one protocol only going into the platform tier, so that it will be very easy for the platform tier to analyze all of the data together. Now, when we provide a single point of entry or exit from the edge tier, and access to the end nodes beyond the gateway will provide the ideal place for the management and local data processing and analytic. So what happened is at gateway, we will be able to apply the fog computing, where all the data will be sorted, all the data will be analyzed, pre-analyzed in this area. If there is certain things, information that has to go back to the sensors, have to go back to the what we call to the devices, and also into the sensors, so then it can be performed in this gateway mediated edge. Okay, so before it goes into the cloud or before into the platform tiers, so that it can be fully analyzed for all and what we call informations. Okay, so by having the data analysis and processing performed close to the edge will mitigate issue with latency, meaning it will reduce the time delay of in term of the information transformation, as the data does not travel over long distance. Okay, so the data will be closer to the end nodes for to the sensors, to the devices, okay, before it goes directly into the platform tier, into the cloud for the processing. Okay, so instead it will be connected over an optimized link to a private or third party network for processing. So let's see this what we call the illustration here to show how does the edge gateway is placed and how it is performed in the IoT. Okay, so if you can see here in the local area network, in between the devices, for example the sensors, the actuator, so there'll be a routing also in between there. So all of this information will be gathered into the edge gateway here. So this one will be the middleman or middle devices that can do all the sorting, all the aggregation of the information, and also can do also analysis. Okay, uh, so that it is closer towards the devices. So if let's say some information or some something, there is some wrong data that found in the analysis, in the pre-analysis, before it goes into the wide area network, or before it goes into the platform tier, uh, it can be easily transformed back into the devices directly, like this one. Now let's see the capability of the edge gateway. Okay, so the first one is local connectivity through wired serial bus and also short range wireless network. So it able to give local connectivity between the what we call the edge tier towards the platform tier. And then network and protocol bridging, supporting various data transfer mode between the edge nodes and the wide area network, asynchronous streaming, event based, and also store and forward. So this is what we call it can bridge between the network and also the protocol. Different network, different protocol can be bridged through the edge gateway. And then local data processing, where all the data can be aggregated, transformed. It can also filter the redundant informations. It can do some consolidation and also analytic before it goes into the platform tier. And then device and asset control and management points that manage the edge nodes locally and act an agent enabling remote management of the edge nodes via the wide area network. So meaning that it can manage the device and assets. Can control the device and asset first in the edge tier before all the information is gathered in the platform tier. And then site-specific decision and application logic that are performed within the local scope, meaning that um, it can perform local analysis of the data, and then it can transform back towards the end nodes. What are the acts that it can be taken before what we call we perform a thorough analysis of the whole informations in the platform tier. Okay, now let's see the connectivity of the devices in between the IIoT. Okay, so how we connect the endpoint, for example, the sensors, the actuator within the IIS can be a simple or extremely complex issue. For example, if we are using LAN connectivity, for example, like field bus, Ethernet, or Wi-Fi, the issue will be readily resolved, meaning that it is very simple. The connectivity is direct. We know it is Wi-Fi, it is Ethernet. Okay, so however, it will become a problem in connecting the sensor in remote areas where the power and communication option may be limited. Okay, so for example, there is shortage of power, or it might be the internet connection is not so powerful, so it will become a problem. Consequently, a vast array of communication technology has risen to try to fit this scenario, and it also can help to make the connectivity between the devices and the machines easier. However, this universal connectivity is one of the enabler of the industrial internet, so we should not complain. Now, in the architectural, what we call architecture of the IIoT, the role is to make sure that connectivity will play its foundation in providing communication between the end nodes. Okay, so this one, it will play major role in the interoperability, integration, and also composability. So what happened is, to make it easy for us to understand. Okay, so when we want to integrate all of the devices, when we want to integrate all of the um, sensor or actuator, of course, it require common signaling and protocol. For example, Ethernet. Okay, so then we also need the interoperability in order to make sure that it function, right? So as we see in the edge gateway previously, we want it to operate together, although they are using different type of language or different type of connection. Okay, so in order to allow this interoperability, it require the same data format, which is syntax. Okay, whereas syntax is the structure of the statement in a computer language, and a common method for the understanding the meaning of the symbol in a message, or we call it as semantics. Okay, and the last one is composability, where the ability to understand what is the intended message that the user want to convey to the other party. Okay, so consequently, when we speak of technical interoperability, we mean the bit and bytes using common interface, whether it's wire or wireless. And then synthetic interoperability require that a common protocol is used to communicate over the common interface. Okay, so meaning that the overall thing that we want to say that although we are using different actuator, different sensor, different protocol of each of these devices, in the end we want the end party, the end area there, it can read all of these things, so that all of the message is accepted and can be analyzed. So that's why we need a common language, a common what we call syntax, so that and semantic, so that the data can be gathered and also can be read by the machines. In order to make sure that connectivity can happen, the IIS using the what we call two functional layer of communication. So this one come from the OSI data model. Okay, so this OSI data model is already there for decades. So usually it is used in the connectivity for the computers. Although later we are going to look into in the IoT, there are simplification of the layer for this one, but we look into the what we call the normal OSI data model first. Okay, so as for the IIS connectivity, they divide it into two functional layer, which is communication transport layer and connectivity framework layer. Okay, so for the communication transport layer, it provide the means of communication between two end nodes. As it will provide a common interface and protocol. So the role is to provide the technical compatibility and interoperability between the two nodes, and the function relate to layer 1 to layer 4 of OSI data model. We will see the OSI data model, don't worry. Okay, just mentioning to you first what is communication transport layer and connectivity framework layer. Okay, so for the connectivity framework layer, the purpose will be of the function in this layer is to provide the unambiguous format, syntax, and semantic of the common communication protocol. So usually this is from layer 5 to 7 of the OSI model. So what is OSI data model? It is open system interconnection model. Okay, so that's the short form for OSI. Okay, so it is a conceptual framework which is used to describe the function of the networking system. So this OSI model will characterize the computing function into universal set of rules and requirements, so that it can support the interoperability between the different product and also software. So this one, there will be a 7 layer, which are physical, data link, network, transport, session, presentation, and applications. Okay, so this OSI data model has been used for a long time. It is started from 1984, which means it's already been there for 38 years. Okay, so it is what we call it is created by the International Organization for Standardization, which is the ISO. Okay, so this is to make sure that all of the language is the same for all of the developer. Okay, so then, although it is not always mapped directly to this each of this layer, but OSI model is still used when we want to describe the network architecture, because in the end, all these things supposed to have being applied in the communication, although it can be simplified in a way. Okay, later we will see what are the simplification that used in the for the OSI data model for the IoT. Okay, so this is how the layer of the OSI, okay, OSI data model. So it starts with the physical layer, and then it goes to data link layer, going into the network layer, and then transport layer. So this four layer will be under the communication transport layer, and another layer will be session layer, presentation layer, and application layer. This is for the communication framework layer. So we will see one by one on the description between the from the physical layer to the application layer. Now let us look into one by one of the OSI data layer. The first one is physical layer. So this is the lowest layer for the OSI model. So this layer concern about the electrical or optically transmitted raw unstructured data bit across the network from the physical layer of the sending device to the physical layer of the receiving device. So usually it is concerned about the device itself. Okay, so it can include specific for example, the voltage, the pin layout, cabling, radio frequency. So in this physical layer also, it concerned about the resources, for example, the network hub, cabling, repeaters, network adapter, or modems. Okay, so this is more into the physical things, the electrical physical things that we have on how to transmit the data. Okay, and then the second one is data link layer. So this one is directly connect nodes used to perform nodes to nodes data transfer. Okay, so it concern about the transferring the data from one nodes to another. Okay, so this one, the data will be transmitted through package into frame. Okay, so it can also correct error that may have occurred at the physical layer. Okay, so this data link layer will encompass two sub layer, which is media access control, which is MAC, which this one MAC provide flow control and multiplexing for device transmission over a network, and the second one is logical link control, or LLC, which provide flow and error control over physical medium, as well as identify line protocol. The next one is network layer. So for the network layer, the responsible is to receive frame from the data link layer and then deliver them to their intended destination based on the address that contained in the frame. Okay, so usually this network layer will find its destination by using the logical address, for example, the IP address. For this layer also, it is very crucial component to quite literally route information where it need to go between the networks. Okay, so meaning that this network layer, it determine the correct address for the information to be sent. Okay, so after through the network layer, it goes to the transport layer. The transport layer manage the delivery. Okay, so once the network layer already confirmed with the address and everything, so transport layer will transform the data, manage the delivery and error checking of the data packet. It regulate the size, sequencing, and also ultimately the transfer of data between system and host. Okay, so one of the what we call example of this transport layer will be the TCP, or transmission control protocol. Okay, now the next section is session layer. So this session layer will control the conversation between different computers. So it manage and it set up, it manage, and also terminated all of the connection when it comes to this session layer. So this session layer will also include authentication and reconnection of the network. Okay, so the next one is presentation layer. The presentation layer format or translate data for the application layer based on the syntax or semantic that the application accept. So once the data is accepted, so this presentation layer will what we call, we translate it into something that able to be read in the application layer, so that it can do the encryption and also description of the data based on the required information that needed. Okay, so lastly, it is the application layer. At this layer, both the end user and the application layer interact directly with the software application. So for example, we do have the Office 365, we do have other software or web browser, so that we will be able to what we call to look into the data in a readable manner. Okay, compared to in the programming in apa rather than in the software and also the programming language, we will be able to see it in on the screen in what we call in a way that we can read it. Okay, so that's where the application layer take place, because all this data will go into to interact with the software, so that software will transform it into something that we are able to look into. Okay, so this application layer also identify communication partner, resource availability, and also synchronize communication. So that's it for this part. We're going to continue in part 2.